Hey guys, so this is just a quick video to help with the small angle approximations. So it's one of the new topics on the new A-Level. So this is for Edexcel mainly, but it also applies to AQA and such, or anyone who's doing a degree or anything engineering related. We need small angle approximations. So we're just going to do a couple of questions to just sort of show where the formulas are used and how you use them. So question 4. We've got to show using small angle approximations where appropriate. The limit as theta tends to 0 of 4 sine theta minus 2 theta divided by tan 2 theta is approximately 1. Right, so let's have a good tackle on this. So the first thing we need to use is the small angle approximations. Now if this is A-level that you're using, these are given in your formula books. You don't need to worry about memorising these. So let's use them where appropriate. I have 4 sine theta here. Well, we know sine theta is theta, so that's 4 times theta. So let's start with this one. So question 4. 4 sine theta, so that's 4 theta. Just using sine theta is approximately theta, so that's 4 theta. We've got minus 2 theta, so the numerator is 4 theta minus 2 theta. So let's not simplify it just yet. Well, let's do the denominator as well. We have tan 2 theta on the denominator, so where you've got a theta here, it's going to be replaced with a, or where you've got a theta here, if you replace it with 2 theta, it's approximately equal to 2 theta as well. So that's divided by 2 theta. Well, let's simplify this. 4 theta minus 2 theta, nice and easy, 2 theta. Minus my bad theta symbols. Divided by 2 theta again. Alright, nice and easy. 2 theta divided by 2 theta. There you go. We have shown now that this is approximately, I should be using approximate symbols here when I'm using the small angle approximations. So 2 theta divided by 2 theta is approximately 1. And there we go, using the angles where the approximations were appropriate, we've deducted that this is 1. Perfect. Question 5. Let's have a go at this. A little bit more involved. We've got a cos now. So, the limit as x tends to 0 of cos 2x minus 1 divided by 2x times tan x is approximately minus 1. So let's start with the numerator. Cos 2x, well, this is my formula for cos theta, right? This is approximately 1 minus theta squared over 2. Now the key thing with cos is make sure wherever you've got a theta here, you replace it with a full expression. So for our example, it's going to be 2x all squared. So let's do it and we'll see what happens. So this is 1 minus, so we're dealing with x's now in our question, so let's use x. So that's going to be 2x all squared. 1 minus 2x, that is a 2, believe it or not, 2x all squared, divided by 2. So that's my numerator. Sorry, not just yet. Let me just do this in brackets. We've got a minus 1 at the end as well. Don't forget the minus 1. I nearly missed it. Minus 1. And this is all divided by 2x times tan x. Well, tan x is approximately theta, or tan x will be approximately x. So that's 2x times x. That's 2x squared. So, we're getting there. Let's finish it off. Let's simplify this bit here first. So, 1 minus, well, what I have here is a 1 and a 1 on the outside. So these ones are just going to cancel straight away. So we're going to get left with a minus here. So I've got minus 2x all squared. Well, that's 4x squared. 4x squared. And that's divided by 2. And the full expression, so my denominator as well, is 2x squared. We don't need to simplify anything there. Well, what's going to happen here is I'm going to get left with, I'm losing my voice. I'm sorry guys, I'm losing my voice here. This is going to cancel to 2x squared. My denominator is still 2x squared. Oh no, my voice is really going. And hopefully you can see that this just cancels to give us approximately minus 1. I hope that's nice and easy to see, guys. So there you go. So just a couple of questions on the small angle approximations.